Welcome. In this video, we are going to go over the class discussion for Unit 1, Activity 1. The graph below shows the relationship between the number of bicycles a company produces and the company's costs. So let's start by defining X and Y in this situation. So our X variable represents the number of bicycles. That's here. The Y variable represents the cost in dollars to produce the bicycles. Next, what is the y-intercept of the line? How did you find it? Well, the y-intercept is right here, and let's label that with a color that stays. The y-intercept is at 0, 2000. And how did we find it? We looked for the spot along the vertical axis that intersects our line. And please write that out in your own words in this space here. Let's continue. Part C, explain, that is, interpret what the y-intercept means using the context of this problem situation. So if you recall, our x variable is the number of bicycles, and our y variable is the cost in dollars to produce those bicycles. So what is our y-intercept again from the previous part? We know it is 0, 2000. And again, the x variable is number of bicycles. And the y variable is cost to produce. That tells me that when 0 bicycles are produced, the cost in dollars is 2,000. And actually, this is redundant here, so let me erase that. So the cost is $2,000. So you might be asking yourself, how does it cost $2,000 to create 0 bicycles? Well, most businesses have some kind of overhead cost, some basic cost that they have to pay no matter what, no matter how many widgets, or in this case, bicycles they produce. This bicycle making vendor will always have to pay this amount of cost. And it doesn't really say per month, per year, per day, we don't know. I just know that this vendor has an overhead cost of $2,000 that no matter what, even if they produce 0 bicycles, they have to spend this amount. Part D, what is the slope of this line and how did we find it? Let's start with the how. And I'm going to start by sketching out 2 points. This is x1, comma, y1. And up here I have x2, comma, y2. And let's ignore the values of the points right now. And let's just remember what slope tells us. Slope is the rise over the run, or as we talked about it, the change in y, so that's the up and down value is the change in y, the rise, over the run, and the run is left and right, so this is the change in x. So we have to figure out by how much did y change? Well, y started here, the vertical value, and ended here. So what is this distance is what we want to know. What is that change in y distance? Well, to find a distance, let's start with the larger value. And the larger y value is up here. So this is our larger value of y2. And so m represents our slope. So I'm going to start with the y2. That's this higher value. And here's this lower value. And if I want to know this change, I have to start with the larger y, then subtract the smaller y. And the smaller y is y1. So let's go ahead and do that. And the same thing with x. If we want to know the change in x, so the left and right change, I have to figure out what this distance starting here to here is. And so this is the larger x value. Here's the smaller. And so let's subtract x2 minus x1. And this is our formula for slope. And really quickly, I started this with larger minus smaller values for both. You can swap them. You can actually go ahead and write this out as y1 minus y2 over x1 minus x2, and you'll get the same answer. In this case, you should get negative values for the top and bottom, which will make a positive. But anywho, no matter which way you write it out, you will always get the slope. If you think you might struggle with that a bit, I would just stick to this for now. And just remember, this is the up and down change, so the change from this lower point to this upper point. And then we subtract the left and right change, which is the change here, from this lower x to this upper x. So up and down change versus left and right change. Okay, so now let's go ahead and pick a couple points. So let's pick some nice points. We already know one of them. Here in red, we have 0, 2000 is our y-intercept. And my advice to you is if you can find a point that has a 0 in it, use it. Your arithmetic will be much easier. And let's pick another point. And when I say pick a point, I'm not going to pick something here that I have to guess at. I want something that crosses these grid lines nicely. Like here's one example of a really nice value I can use. Here's another one right here. And they're nice because they intersect these vertical and horizontal grid lines at numbers we can easily read. And there are more examples like that. Like I have one here, here. So there's several points we can use. I am going to pick this one and label it in green. So I'm going to pick 300, comma, and here I have 3,000, here I have 4,000, and right here's their midway point, so that's 3,500. So now that I have my 2 points, I can go ahead and write this out as 3,500 minus 2,000 divided by 300 minus 0. And if you notice, I kept the colors. And why did I do that? This will help you see that this is 1 point. So this is 1 point here. And this in red is another point. So again, it doesn't matter what order you have these in. I could have written 2,000 minus 3,500 divided by 0 minus 300, so long as I kept the pairs of numbers stacked vertically on each other like this with a minus sign in between. All right, so what are we going to get? So on your numerator, you should get 1,500 divided by 300 in the denominator. And this gives you a slope of 5. Part E, explain, that is, interpret what the slope means using the context of the problem for this situation. So if you recall, we found that m equals 5. So the slope is 5. And for our first part of this problem, we labeled x as the number of bicycles and y is the cost to produce those bicycles. And so let's recall what slope is. So the change in y, again, up and down over the change in x. And that's left and right. And so we have our slope is 5. And any whole number can be written as a fraction just by adding a 1 over it. So that means the cost that y values changes by 5 for every 1 change in bicycle. Part F, let's write the equation of this line. So here we have the y-intercept again, which we know is 0, 2,000. And let's recall that our slope is 5. So I'm going to show you 2 different ways to write this line. First, let's use the slope-intercept form of a linear equation. That's y equals mx plus b. And right now we know what m is. M is 5. And in this case, our b is 2,000. So our equation is y equals 5x plus 2,000. And now I'm going to show you a different way. And this way's a little longer. But consider this a review in case you don't remember what the point-slope form of a linear equation is. And this is y minus y naught equals m times x minus x naught. And so I'm going to pick two different points for this. Let's go with this first point, which we've used once, 300, 3,500. All right, so now using this slope and this point, we should be able to get this same line. So let's go ahead and write y minus our y naught. This just means our particular choice for x and y. So this is our x naught, this is our y naught. And if you see any letters like this with a 0 under them, it's pronounced naught. So this would be pronounced as x naught. Anyways, that aside, we have y minus 3,500 equals 5, which is our slope over here, times x minus 300. And now let's go ahead and do some arithmetic. So we want to apply the distributive property, so we need to multiply 5 times x and 5 times 300. So we have on the left, and nothing has changed, y minus 3,500. So always write down everything that has remain unchanged and your equal sign so you don't lose track. The only thing that's changing is on the right-hand side. 5 times x is 5x, and 5 times 300 is 1,500. Now we need to add 3,500 to both sides. On the left-hand side, negative 3,500 plus 3,500, that's just going to be 0. So I'll be left with y equals, in case you need to see that, I would write down that that's 0. So y equals 5x plus 2,000. And you notice that we ended up with the exact same equation in slope-intercept form. So that's y equals mx plus b, using a different method to get that line. So hopefully this was a nice little review on how to use point-slope form. Part G. A classmate looks at the graph on the previous page. In this case, I have it right in front of you here. So a classmate looks at the graph and notices that when the company produces 100 bicycles, and that's here, the cost is 2,500. So this is the point. 100, comma, 2,500. This classmate concludes that the company's cost is $25 for each bicycle. Although this calculation is correct, the interpretation is incorrect. Compare her calculation and interpretation to your answers from parts D and E. Now let's recall what we found in parts D and E to start. So in part D, we found the slope, m equals 5. And in part E, we wrote that for every bicycle produced, the cost increases by $5. And that's the y. So now, while your classmate is correct that at $100, the cost is $25 per bicycle, we can give an example of how this interpretation is incorrect. Let's look at a different point here. So this is 400, comma, 4,000. And let's see what this comes up with. So we have $4,000 is the cost to produce 400 bikes. And for easy division, you can just cross out matching zeros since it's dividing by 10. So we end up with $40 over 4 bikes, and we can continue simplifying, and we end up with $10 per bike. So what just happened here? How do we have $25 for each bike here and suddenly $10 for each bike here? Well, what your classmate found wasn't actually a rate of change. A rate of change, you need to actually find 2 points like we did and subtract the differences in y, or find the difference in y, and then find the difference in x. And that will give you an actual slope. What your classmate found is the fixed cost here. So if the company were to only produce 100 bikes, then it would cost them $25 per bicycle. But since these overhead costs are fixed, say this is rent, say this is electricity, water, whatever the overhead costs are, those are fixed. So the more bicycles the company produces, the less it's going to cost, since they can spread this $2,000 out over more bicycles. So suddenly when they produce 400 bicycles, the cost is going to drop by to $10, so by $15 per bicycle. And we can keep going. At 700 bicycles, what's that going to give us? 700 is 5,500 bicycles. So when they produce 700 bicycles, that's here, the cost is 5,500. And let's quickly divide that. I'm using a calculator off screen that you can't see, and you can do the same. And the cost suddenly drops to about $7.86 per bike. So no matter what, their overhead is fixed. And the more bikes they produce, the less it's going to cost to produce them. In general, though, we can say for each new bike, it's going to cost them $5 additional to produce each new bike.